Hello, hello. This is our video for Activity 7. As you'll recall from Monday's lecture, our topic this week are ANOVAs. ANOVA, again, stands for Analysis of Variance. Okay, so this week in particular, we were talking about one-way ANOVAs. So these are defined when we have a single dependent variable of interest and 3 or more levels of a single independent variable of interest. Okay, so the 1 indicates how many independent variables there are. So one independent variable, and then it can be split or grouped into several different categories, right, or it's a nominal type of data. So we have a couple of examples in this activity. The first set of data that you're going to be working with is for a simple ANOVA. We also called this our independent sample or a between subject design one-way ANOVA. And you've got 2 different data sets, one from Southern California schools and one of Northern California schools. So your scenario is highlighted here. Okay, you're going to use a one-way ANOVA on each of these data sets separately to see if location or school location is going to have an effect on relative body fat composition. Okay, so I've put in the pathways that you're following and as well as what to include in your output tables. Since we did an example of this in class on Monday, which there will also be a separate video for, this week I kind of want to let you guys, kind of walk or swim on your own. So this is the part of the semester where integrating information with different sets of data is important. So previous activities, I've kind of slowly let you guys work on your own as we've gone along through the semester. So you have the steps and you've got the flow charts to kind of guide you through how to make this work. But I really want you to think about what the independent variables are, what the dependent variable is, right? Figure out what type of data you're working with, how that information will tell you how to organize the data within the spreadsheet such that it matches the test that you're actually running. Okay, so use the information that we went over in class to try to figure out how to run this test. And then I have a series of questions in the answer sheet. They've been divided by whichever data set you're working with. Okay, so the first one, basically the general layout of the questions for the entire activity are going to be evaluating the assumptions test, then evaluating the main effect, and then, as we had mentioned in lecture, for ANOVAs particularly, if we have a significant main effect, right, if there is at least one significant difference between any of our groups, post hoc tests are going to be necessary to analyze so that we know which groups actually have the differences. So there is a question for both the just for the Southern California school data set, and you're going to indicate if there were any significant pairs. If you don't think you need to look at post hoc tests based on the results of your main effect, then you can just put NA. Okay. The Northern California is kind of going to be the same. You're evaluating if you've met the assumption of homogeneity of variance, identify what the p-value for your main effect is, as well as the interpretation of that p-value. Okay. Onto the repeated measures ANOVA. This also has 2 different small data sets. Please know that this is a little bit more representative of types of samples that maybe you guys might find in like a master's thesis or something, where usually sample sizes are a little bit lower, right? But still a valid data set to investigate. Okay, so both of these are going to be repeated measures ANOVA. Okay, for the HIT protocols, let me toggle back to the instruction sheet. Okay, I kind of give you a little bit more of a detailed scenario on what was being measured. So you'll run an analysis or repeated measures analysis of, again, all of the pathways and instructions are in the instruction sheet, and you can use the example that we went over in class, right? But you're going to run a repeated measures on the HIT protocols, and then I've also added an additional scenario where you're going to run another repeated measures ANOVA on the time of day. Okay, so in this one, we've had people come in on 3 separate occasions to try 3 different protocols. In this data set, we're still using one person for 3 different measurements. We're just having them come in at different times of the day, exercising the same protocol for each of these so that that becomes a constant. Okay, so those are kind of our practice data sets for information that we've covered this week. In the test for results, you have 3 different data sets. Okay, the way that you treat these data sets is completely up to the scenario given to you in the instruction sheet. So based off of the information you get from this section here, you have a list of questions in your answer sheet where you're going to identify variables, right, independent versus dependent, as well as the type of data that they are, what test you decided to run based on this variable information, okay, and then you're also going to list the null hypothesis for the main effect of the given test that you've chosen. In addition to that, you're going to list the assumptions that must be met in order to run the test you chose. And then this last part here, part D, this will be the same for each of the data sets. The questions are identical, but this is the part that's largely going to change because I'm asking you to provide relevant information for the results of your test. So the relevant information can be found on the instruction sheet. Okay, so these 3 are built into the questions that I've already put into the answer sheet. This is the stuff that is the relevant information. So let's say that you decide you're going to run an independent t-test for one of the data sets. Okay, in that part D area, or that relevant information area, you're going, if you chose an independent t-test, right, you would put the p-value for the homogeneity of variance, how you would interpret that p-value, and then you would put the p-value for the main effect or the t-test, and then also an interpretation of that p-value. Okay, so each type of test has a different list of statistical values that are of importance that I think you should know how to find, as well as how to interpret. So there's a little bit of review built into this section of the activity. But everything that is in this activity you guys have already seen before. So I encourage you to use your resources, revisit the video from the lecture data that we covered. I would also highly advise looking at the decision tree flowchart. This has all of the assumptions as well as all of the different pathways to kind of help you figure out, like, okay, we have a parametric dependent variable, what type of variable is our independent? And then as you make these decisions in your scenarios, that should help lead you to what type of test you should run. Okay. Additionally, since ANOVAs are new this week, I would also advise that you look at the ANOVA SPSS output file that is shared on Beachboard. I put links in the supplemental resources section for this week's module, but this will be helpful in walking you through how to read the outputs, because they are starting to get a little bit more complex. There's a lot more tests that you have to look at. So this kind of guides you saying, like, first in a one-way or simple independent samples one-way ANOVA, right, we would have to look at homogeneity of variance first to make sure that any correction factors, if needed, are being applied, right? Anytime we have a p-value, remember there's a null hypothesis that goes with that p-value. So understand where to find those p-values, how to interpret them, right? So for Levene's test or homogeneity of variance, we're either saying we have equal variances or unequal variances, and based on that p-value for Levene's test, that tells us which table to go to for the p-value for our F statistic, right, to let us know if we have a difference between the means for our ANOVA. Additionally, from there, if our F ratio or F statistic is significant, right, there's a certain pathway that'll take us to post hocs, and each post hoc test or each pairwise comparison that we put together is going to have its own null hypothesis, similar to that of a t-test. Okay, so then we also have p-values for our post hoc tests or our pairwise comparisons, in which we're evaluating if we have differences between certain groupings within our samples. I've also included another output for repeated measures one-way ANOVA. Okay, so again, starting with our assumption test, and then this will walk us through if we don't have sphericity, right? We talked about using different adjustments and how we evaluate which adjustment to use. And then those adjustments, or if we assume sphericity, right, there's different rows in the ANOVA table, which we call test of within subject effects table. And then based off of the results in that table, right, we can evaluate the null hypothesis for the main effect of our test. And if we have a significant effect present, we need pairwise comparisons, which again is very similar to the one-way ANOVA that we just talked about for independent samples or between subject effects. Additionally, within the flowcharts, and I'll do this a little bit more detailed in a different video, you should be familiar with the ANOVA table. Both of these tables are in the lecture from this week, but there will for sure be a question on the exam where you're given certain values within either one of these tables, and you would need to be able to identify what type of ANOVA is being presented to you, and then how to calculate the F ratio, in addition to estimating a p-value from your F table based on the calculated F ratio that you get, and that's going to be a comparison between F ratio and critical value. Okay, so as indicated on your answer sheet at the very bottom, this week, because the Excel data pretty much is just a copy-paste or reorganize and copy-paste into SPSS, all I want from you is your SPSS output, just to make sure that all of your tests came through, and then that way if you have any mistakes on your answer sheet, I can go back and check to see if there was anything wrong in your output. And then as always, you're going to submit your answer sheet. All of this will be due by next Monday at 11:59 p.m. Okay, due dates are also listed on Beachboard if you need to keep track of those. And then if you guys have any questions, just let me know.